This video and the next several videos, I'm going to just work through several of the homework problems, section 3.3, page 187 in the text. And all of these we're doing a first derivative analysis, what I call the first derivative analysis. We're going to find the open intervals where the function is increasing, decreasing, and we're going to find and label, categorize any relative extrema, relative max, relative min. And so I think the first one, I'm not going to work through all the problems here because so many of them are very similar. If you can do one, you can do a couple others that are very similar to it. But I want to make sure and sort of comb through several of the different varieties so that you have a pretty good feel for how each of these works. So the first one I'm going to play with here is number 23. Don Mattingly was number 23. The function is f of x is negative 7x to the third plus 21x and plus 3. And so we're off to the races. So first derivative analysis, it certainly requires the first derivative. And so that's negative 21x to the second plus 21. That shouldn't be too much of a hassle to find that. And we're going to find the critical values. We need to cut the number line in the various locations it needs to get cut. And those cut values come from the critical values. Type 1. That's where the derivative is equal to 0. Let's see if I can do that without fouling it up this time. So this is negative 21x to the second plus 21 is equal to 0. Factor out negative 21. I get x squared minus 1 is equal to 0. Negative 21 equals 0 does not generate a solution. There's no variable, so there's no solution. If I have x squared minus 1 equals 0, we could go ahead and probably the safest thing to do is to factor that. But by hook or by crook, we get x equal negative 1 and x equal positive 1. And so that cuts the number line. Negative 1, positive 1. And so now we need to choose a representative from each of those regions. Region from negative infinity to 1, I'm going to choose negative 2. You can choose any number you like. You might as well make it an easy one. For the interval from negative 1 to 1, I'm going to choose 0. And the interval from 1 to infinity, I'm going to go ahead and choose something simple like 2. And so now we need to compute. This is the actual first derivative analysis. We're going to determine if the function is increasing or decreasing on these various intervals. And so we have the derivative evaluated at, now notice, the representative values you evaluate using the derivative. Later on, we're going to evaluate the actual cut values. Those are evaluated using the original function. Make sure you have notated and you have delineated in your mind when you use the derivative and when you use the original function. The most common error is to cross those wires. So we have f prime of negative 2. F prime is right here. So that's negative 21 times negative 2 to the second plus 21. So that's negative 21 times 4 is negative 81 plus 21. That's negative 60. The 60 part is not what's important. It's the fact that it's less than 0 is what's important. So on that interval, the function is decreasing. So this curve is decreasing on that interval. And then we need f prime. As Dr. Guffey used to say, you had so much fun, do it again. So same song, second stanza, same song, third stanza. So we have f prime, and we need to evaluate that at 0. We need to evaluate that at positive 2. Neither of these is particularly challenging, particularly since this is an even function. This is negative 21 times 0 squared plus 21 is positive 21. The fact that it's 21 is not what's important. The fact that it's positive is what's important. So there the function is increasing. So we don't know that we have a minimum, we have a potential minimum, a potential relative minimum. More on that in a moment. And then f prime of 2, it's going to be the same computation because this is an even function. Negative 21 times 2 to the second plus 21 is, once again, negative 81 plus 21, which is equal to negative 60. That's coincidence, don't read too much into that, but it's less than 0, which means the function is decreasing. So we have the intervals of increase and decrease. We now can say for sure that f is increasing. Where is f increasing? On the interval from -1 to 1. We want open intervals. All the intervals of increase and decrease should be open intervals. -1 to 1. And then we have f is decreasing on these other two intervals. The interval from -infinity to -1, and the interval from 1 to positive infinity. So that's part number 1 of our analysis. Next, we have a potential minimum, because we potentially have bottomed out here, and we have a potential relative maximum. We've potentially maxed out. Oh, by the way, what I've just done here, I don't get full credit. Do you see my mistake? If you're grading me, you should give me like a -4 here, because I didn't do type 2. Type 2 is where the derivative does not exist. And because the derivative is a polynomial, there are none. So I needed to actually denote that. And so there are none because it's a polynomial. Okay, so the last piece is we need to actually check to see if the function actually is defined at -1. So we need to compute f of -1, and we need to compute f of +1, and determine if the function actually is defined there. And so we need to use the original function here. So what we have here is -7 times -1 to the third, plus 21 times -1, and then plus 3. And so what do we wrangle out of all that? That's -7 times -1 is 7. Positive 21 minus 1 times -1 is -21 plus 3. And so that is 10 minus 21 is, I believe, that is -11, if that's correct. 21 minus 10 is 11. And so we have, that is the relative minimum. And then we also need f of +1, which is -7 times 1 to the third, plus 21 times 1, plus 3. And so that's -7 plus 6 is -1. And so we can actually then list those as part of our solution. I'm going to steal some space here. So this is the relative minimum at this, what's the largest and the smallest? The largest is -1 and the smallest is -11. And so we have a relative, -11 is the smallest relative minimum at -1, -11, and we have a relative maximum at 1, I believe that's -1. So find the intervals of increase and decrease, find the function value at the cut value, compute, find the function value with the other cut value, compute, pick the large one, pick the small one. The relative minimum, we know it's a minimum because we're going downhill. We must hit that point, the bottom, and then come uphill. So we know this is a relative minimum. We know this is a relative maximum at 1, -1, and that's all we have. All right. So that's our problem number 23, and that's the whole thing worked out, and hope that was relatively clear. I left out my type 2 critical values. Make sure you don't do what I did. Make sure you get full credit for your work there.